Today we're going to be going over how to use Python and its libraries to analyze data. So before doing anything relating to prediction tasks or machine learning at all, or any operations on a bunch of data, we got to know how to work with it. So I think this was advertised as a tutorial to analyze election data, but I think this year's election has gotten everyone super emotional. So we're going to be doing something a little bit more neutral, which is analyzing NBA game data. So can't go wrong with that. So I think you should see the raw data. It's a lot. It's over 100,000 rows. And it's a collection of every NBA game ever from 1947 to 2015. I got this data from a website called 538, which is a sports, politics, and economics blogging website. You could check it out in your free time. So this tutorial is meant to be like a quick blitz, scratching the surface of Python, Pandas, and Matplotlib. I'm not going to go over things in extreme detail because it's under an hour, and I realize it's impossible to go over everything in an hour. So let's begin. So right here, I initialized a URL that sources to this URL, which is the raw data that I got from GitHub. And we're going to be using Pandas to create a data frame out of this data. So, hold on, there we go. So let's create a data frame. So we'll write, oh, and by the way, I'm using Google Colab. So the way you can access it is by just typing in Google Colab. And then you can find this. It's available to everyone that has a Gmail account. And then you just create new notebook on the bottom. And it directs you to a notebook, which you can do whatever you want in. And so I'm using Google Colab for this. And all right, so let's get started. So I instantiated a URL, and I'm going to feed it into a data frame. So I'll create a variable called NBA, and PD stands for Pandas, which is the framework we're going to be using, and we're going to read CSV of URL1. Index column equals 0, and then we're just going to look at what NBA looks like. So as you can see here, we have a whole data frame, which represents the CSV file. So it has, so in order to read the shape, we can do, hold on, okay, plus NBA shape. So as you can see here, it has, it's a lot of rows, over 100,000, and it's 22 columns. So let's export this data. So in order to display all the columns, I think it's already set to that. So we don't need to do that. If we do NBA describe, it will show us all the data in a very weird form. So yeah, that's how you basically create a data frame. You just write read CSV file. So hold on. All right, so now let's explore our data set. So there's a method called value counts, which returns an object that contains the counts of like the different columns or the different series that you want. So it's going to be in descending order so that the first element is the most frequently occurring. So let's say that we want to look at all the NBA teams and see how many games they've played over the span of like a lifetime. So we'd first, NBA is our data frame. and then team ID is one of the column names, team ID. And then we want to get value counts, which will return, yeah, so it seems like Boston Red Sox played like 6,000, New York Knicks played 5,000, whatever this number. New York Lakers played this amount, so it's in decreasing order, and this is what value counts does. Now, to find the count in each franchise, we do something similar. So Fran ID. It's my cat. So the numbers are not the same, even though Team ID and Fran ID are referring to what seems like the same like teams, but they're actually not. So it seems like Lakers have played 6,000 games, but Los Angeles Lakers played like 5,078. So there might be another team called the Lakers. So in order to like check that out and find what the discrepancy is, we can create a subset of the data set. So Pandas has a method called woke, which literally it looks like this. So this is the method name. And this allows you to access a group of rows and columns by labels or a Boolean array. So we're just going to get a subset of the data frame. So this is what we do. So NBA low team ID. Wait, no, Fran ID equals okay, so as we can see, what I inputted into this method is a Boolean array. And this Boolean array, if you want to see what it looks like, just do code and run what it looks like. Yeah, so it's basically a Boolean array of a bunch of falses because not every single Fran ID is equal to Lakers. And then we're checking for the team ID as well. So there are two team IDs, which are Los Angeles Lakers and MNL, which is Minnesota Lakers, I think. So that's why all the Lakers games added up equal to 6,024, it seems like. So so if we want to explore that further, we can do so NBA. We'd input another Boolean array. So NBA team ID is equal to MNL. And we want to see, if we want to see what the first game that Minnesota Lakers ever played, we would have to input the team ID and date game, which is another another variable, another column name, and we'd find the minimum. So it seems like the first game, it seems like, is 1/1/1949. And if we want to find the very last game that they played, we do the max. So 1959. So they only played for 10 years, and that explains why we probably don't know them. Minnesota Lakers, and we know the Los Angeles Lakers. So let's move on to series, actually, because series are like the foundation of Pandas, and a data frame is based a collection of series. So every single column is considered a series. Okay, so we can create a series manually. Let's just create like revenues equals pandas series. 00 and 1980. Ah, what? Oh, okay. There we go. Okay, so what we did here was just create a column actually with indices 0, 1, 2, and values, whatever these values are. And so series behave like dictionaries in pandas. And Python dictionary is basically like a list of key value pairs. So we can create another pandas series called city revenues, and then we'll try to amalgamate the two together. And then let's create indices. The indices in a pandas data frame or a series don't always have to be numbers. They can be like strings. So you can just write like Amsterdam, like the names for cities, Toronto and Tokyo. And we can just see what it looks like. Yeah, so just simple series. And now we can try to create another series. So this is all the different ways to create a series. Like the first, wait, hold on. I'll just do this one first and then I'll show you. Okay, so it's all good. So the first way we created a series was just inputting like values, just random values for the values. And for city revenues, we manually created the indices. Index is actually a keyword in Pandas series, so it knows that like this index corresponds to this number, this index corresponds to this number, this index corresponds to this number. And in the third series, we instantiated a dictionary, much like we would in Python. So because Pandas is a Python data framework, a lot of the syntax is the same. So now we're going to try to merge the data using a data frame. So create a new variable called city data and create a data frame out of it. Okay, so then employee count. And then city data. Okay, yeah, so it creates a nicely formatted data frame for us. So as you can see, revenue and employee count are the column names. City revenues represents a series. So like we said before, series in Panda, whenever someone says series, just think column. So it's literally just a column. The employee count is also another series. And because, hold on, because there's only two values in the series, the last value is just null. And Pandas does that automatically if there's not enough like data for the entire data frame. It just sets it to null. So yeah, this is how we amalgamate data. We just create a data frame out of it. We just inputted 2 different series inside of the data frame, and it created a data frame with 2 columns. So what else can we do? Let's query the data set now, the NBA data set. So we'll select rows based on the values of our data set's columns to query the data. So for example, if we want to query all the games that are played after 2010 in the original NBA data set, we do something like this. So we can set a variable called current decade, and we'd try to query a subset of the data frame in which, hold on. So year ID, where is it? Yeah, year ID is greater than 2010. So let's go back here and do NBA greater than 2010. So hopefully this should work. All right, yeah. So as you can see, all the year IDs are greater than 2010, and it inputs the rest of the data frame along with it. So what else can we do? Okay, so we can also query for all the friend IDs. So like the basketball teams that end in ERS, like Lakers or Cavaliers. So the way we do that is set another variable and query much like we would the other query. So NBA fran ID. We need to form a string out of it, so string, and then ends with ERS. So like Pandas is very, very human friendly. Like the syntax is like pretty much pseudocode. So much of it is like pretty self-explanatory, and like the rest, if you want to experiment around with Pandas, you can just go to, there's a whole, they have really nice documentation for Pandas. It's extremely thorough, and it comes with like examples on the bottom, so you can go and, you know, just play around with like different just different methods and like different ways of manipulating the data. So when in doubt, just look at the documentation. All right, so what else? We can search for Baltimore games where both teams scored over 100 points. So this one's a little bit longer. So if we do new cell, okay, so you can set a new thing like over 100, and we want so games where both teams scored over 100 points. So and we do not want duplicates, by the way. So so we do something like NBA, hold on, okay, so NBA points greater than 100, right? So I don't see it. Oh, okay. Okay, so points is greater than 100. Then we want the opponent's points to also be greater than 100. So we set both of these to greater than 100 is greater than 100. And wait, forgot it. I think depending on the language, like this one would be applied to bitwise operators, and 2 would just be equivalent to and operations. So, but I think Pandas accepts just 1. So we can stick with 1 for now. And so NBA opponents points greater than 100. And NBA team ID. Okay, wait, I think this is good. Yeah, so again, like super self-explanatory. Just look at the documentation. Oh, hold on. Wait, what did I do wrong? It's weird. Mm. Oh, okay. Just extra sign. So yeah, this outputs all the games in which opponent ID and the points of both teams are greater than 100. So if we would want the points are greater than 100 for like all the teams, all the Baltimore teams, then we do NBA team ID is equal to BLB, which is the team ID for Baltimore, which is again. Oh, and forgetting the ampersigns. There we go. So there's only 5 games here. So it gets smaller, and the smaller, the more specific you get. So okay. What else can we do? All right, so now grouping and aggregating data works very much similar. It's very similar to like grouping and aggregating in MySQL. So before, remember we had, we created like mini data frame called city data. We created 3 different series called revenues, city revenues, and city employee count. So if we want to sum over city revenues, we just do city revenues sum. And then like max, there's also max. And we can also do the group by just like we do in MySQL. So NBA group by Fran ID. We can specify a sort. So we don't want to sort because sorting takes like more comp power. And it doesn't really matter for this operation because we're just summing over. So we just want to get the franchise ID and the points associated with that franchise, and we're grouping it. So like basically what this operation does is it scans through all the franchise IDs and sums over the number of points for every single franchise. So that's another thing you could do. What else? Okay, we can also answer the question of, we can look at one specific team, look at their season year, and see the number of wins and losses they scored during that season. So let's say that we want to look at Golden State Warriors 2015 season and check their wins and losses. So we want to do something like so NBA Fran ID equals Warriors And in 2015. Oh, okay, wait. Oh. And then is playoffs is a Boolean. So I think if it's 0, then it wasn't a playoff. And if it's 1, then it was. So in order to look at all the different wins and losses, we group by is playoffs, and then we group by the game results. And then we want the game ID. So is playoffs. Okay, cool. So we looked at the season in 2015. We grouped by so if you specify the order in which you specify like the columns is the order in which it's going to group them by. So we ordered by is playoffs first. We looked at the game result per each playoff, and we saw the number of wins and losses. So significantly more wins than losses for the Warriors, so that's pretty good. Manipulating columns section works much like the rest of the sections. That's basically just like adding new columns if you want, manipulating the other columns. So representing data is much more interesting because that's like you're looking at pictures and you're looking at what the data actually looks like. So you don't have to import matplotlib for this because it's actually inbuilt. Some of the methods from matplotlib are inbuilt into the pandas module. So both series and data frame objects have a .plot method, and it's a wrapper for matplotlib. So by default, it creates a line plot. So if we want to visualize the number of points that the Knicks scored throughout a given season, we could do something like this. So NBA, and then all right, so year ID and points are the X and Y axes. And so it plots this for you. If we want to, and you can tell that there are several peaks around 2000, several downward peaks in 2000, 2010. So it does not look like they did well those years. We can also create something like a bar plot, and at the end you would just have to specify that kind equals bar. So we could do something like, hold on. All right, so now that creates a bar plot of all the different, like the top, so head and tail are the two different specifiers in pandas. So head is just the first, you can create like 5 if you want, or 20. But head just specifies the top 10 or the top number, like n number of teams that are at the top of the data frame, and tail just represents the last n rows in the data frame. So we can also do tail if we want. And they have a lot less scores, actually in the hundreds instead of in the thousands. So let's do head. Yeah, like these teams have scores in the thousands. So it seems like this this data frame is grouped by like the number of scores or something. Okay, and lastly, we can show the franchises with the most games played. And we can create a pie plot showing the count of their wins and losses during that season. So, like, for example, we can take Miami Heat in their 2013 season, and we can show, like, how well they did during that season. So, same thing as before. So we want to specify Miami Heat, and we want the year to be 2013. And we want the value counts of the game results, and then we want to put that into a pie chart. So game result value counts plot times equals pi. No, it's always a syntax issue. Happen here. Okay, another. I think we're good now. Yeah, there we go. So they have a lot more wins than losses during that year. And that's pretty much, this is all the material that I have for today. So Pandas is very ubiquitous, and you can use it just to take a glance at your data before you do any like hardcore analysis, or you like begin like making prediction models for it. So this is just one framework, and there's many others. So at the top, I have like all the different sorts of frameworks that you can use. So data visualization, we use Matplotlib. You can also use Seaborn. Apache, Spark, and Hadoop are used for like very, very big quantities of data. Scikit-learn used for ML usually. TensorFlow, PyTorch usually for deep learning. So Pandas is just like something that you can use to look at your data, do simple statistics with it, and just yeah, like nothing too fancy, but it is very, very powerful and very useful.